Hey guys, this is that next video I mentioned before. We're going to be covering coterminal angles and reference angles. Let's go. Hey guys, and welcome back to your channel. This is Franck, and if you have not done so yet, go ahead and subscribe to the channel so you can get more videos like this one. Today we are going to be covering coterminal angles and reference angle. And so with that, the first thing I'm going to do here is draw my XY plane. And I'm going to have the point P here of coordinate XY. And after connecting the point P to the origin, I'm going to have an angle here that I'm going to name theta. Alright, so for some terminologies, the point P here is called the terminal point for the angle theta, and the segment OP here is what is known as the terminal side for the angle theta. The point P here could be sitting on either of the quadrant of the XY plane. In this particular instance, it's sitting on the first quadrant, but it could also be sitting here on the second quadrant, third quadrant, or even the fourth quadrant. And so, with that, the first thing I want to talk about now are coterminal angles. Simply put, coterminal angles are angles that have the same terminal point. And so, in a way, adding or subtracting a full revolution to any angle would result in a coterminal angle. A full revolution here is considered as being 360 if you're working in degrees, or 2 pi if you're working in radian. Okay, so for some examples here, let's say that you have the angle 60. And so some coterminal angles to this particular angle could be found by adding or subtracting 360 degrees to 60. And so if you were to add 360, you will get to 220. And if you were to subtract 360, you will get to negative 300. And of course, another subtraction here will get you to negative 660. So all of these four angles here are coterminal angles because they share the same coterminal point. Another example here in radian would be if you had the angle 90 degrees in radian, i.e. pi over 2, adding 2 pi, which happens to be 4 pi over 2, to this particular angle would give you 5 pi over 2. Adding another 2 pi would give you 9 pi over 2. Or even subtracting 2 pi would give you negative 3 pi over 2, because that's 1 pi minus 4 pi over 2. And so these four particular angles here happens to be also coterminal angles because they share the same coterminal point. Alright, so with that, let me give you the definition of a reference angle. A reference angle here is going to be the positive acute angle, let's say theta prime, formed by the terminal side of the angle theta and x-axis. And so let me give you some examples here so you can see what I'm talking about. So if you have the angle theta equals to 160 degrees, then this particular angle will be sitting on the xy plane right about here. And so as you can see here, the angle theta prime right here that is formed by the terminal side of this angle 160 degrees, and the x-axis is what is known as the reference angle. And as you can see here, the positive value of this particular acute angle is going to be equal to 180 minus 160. And that would give us 20 degrees. And so in this case, theta prime equals to 20 degrees is the reference angle to the angle 160 degrees. And reference angles are important here because they're going to help us figure out the trigonometric function value of some angles that are not common. And I'm going to talk about that more in one of my next videos. Alright, so next example here, let's say you were given theta equals to 205 degrees. Now this particular angle obviously is going to fall between 180 and 270 here. So this is in the third quadrant, and as you can see here, the acute angle theta prime formed by the x-axis and the terminal side is right here. And so its positive value should be computed by subtracting 180 from 205. And so we're going to have here theta prime equals to 205 minus 180, and that should be equal to 25. Next example, we're going to have theta equals to 355 degrees. That's going to be sitting between 270 and 360. So that's going to be in the fourth quadrant. And so the value of our reference angle here is going to be equal to 360 minus 355, which is going to be equal to 5 degrees in this case. All right, so next example here, let's say you're given the angle theta equals to 30 degrees. This angle falls directly in quadrant 1. And so for that reason, since this angle is already an acute angle, it will be itself its reference angle. So you're going to have here theta prime equals to 30 degrees minus 0, which is equal to 30. Alright, let me give you some examples that are a little bit harder. You're going to have theta equals to negative 150 degrees. Now, this particular angle here does not fall between 0 and 360. So it could be difficult to figure out where to position this angle on the plane here. And so one thing you could do when you have something that doesn't fall between 0 and 360 is to find one of these coterminal angle that falls between 0 and 360. And so since this angle happens to be negative, I'm going to go ahead and add 360 to it. And so the angle negative 150 is going to be equivalent to the angle negative 150 plus 360, which is equal to 210. And so now that this angle falls between 0 and 360, I can know for sure that it's located between 180 and 270. And so I know that my reference angle theta prime here is going to be equal to 210 minus 180, which is equal to 30. Also, side note here, if you're the kind of person who knows how to drive negative angles on the plane, you should have also already figured out that this particular angle falls here if you count the angle clockwise, because that's the negative direction. And so this way you would have also figured out that the angle theta prime will be equal to 180 minus 150, which is also equal to 30 degrees. So it's whatever works best for you. All right, let me give you the next example. We're going to have here theta equals to 560 degrees. And so this angle here again falls out of the range of 0 to 360. So to find a coterminal angle in that range, we're going to have to subtract 360 from this particular angle. And so we're going to have this angle equivalent to the angle 560 minus 360. That's going to give us 200. And of course, 200 here falls between 180 and 270. And so we know that for that reason, the angle theta prime should be equal to 200 minus 180, which is equal to 20 degrees. All right, so sometimes you will also be given the angle theta in radian. So let's go ahead and do some examples like that. So we're going to have our next angle here, theta equals to 7 pi over 4. And so from here, you should notice that 7 pi over 4 falls in between 3 pi over 2 and 2 pi. And that's because 3 pi over 2 is the same thing as 6 pi over 4, and 2 pi is the same thing as 8 pi over 4. And so you can see here that 7 pi over 4 falls in between 6 pi over 4 and 8 pi over 4. And so in this case, our reference angle theta prime should be equal to, as a positive number, 2 pi minus 7 pi over 4. So that's going to give us 8 pi over 4 minus 7 pi over 4, which should be equal to pi over 4. All right, let me give you more examples in radian. So you're going to have the angle theta equals to 5 pi over 6. So this particular angle is going to fall in between pi over 2 and pi. And that's because pi over 2 here is the same as 3 pi over 6, and pi is the same thing as 6 pi over 6. So you can see here that 5 pi over 6 falls in between 3 pi over 6 and 6 pi over 6. And so, for that reason, the angle theta prime should be equal to, as a positive number, 6 pi over 6 minus 5 pi over 6. And that should give us pi over 6, and we are done. Okay, next example, we're going to have theta equals to 17 pi over 6. This particular angle here given in radian happens to be bigger than 2 pi. And that's because 2 pi is 12 pi over 6. And so you can clearly see here that 17 pi over 6 is bigger than 12 pi over 6. And so for that reason, we have to find a coterminal angle to this particular angle that falls in between 0 and 2 pi. And so our job here is to go ahead and subtract 2 pi from this 17 pi over 6. So we're going to have this angle equivalent to 17 pi over 6 minus 12 pi over 6. And that should give us 5 pi over 6. And so if you look at example 8, we've already dealt with 5 pi over 6, and we know for sure that it falls between 3 pi over 6 and 6 pi over 6. And so therefore, the reference angle for the angle 17 pi over 6 should be the same as the reference angle for the angle 5 pi over 6. So we're going to have here that theta prime is also equal to pi over 6. All right, let me give you one last example. Let's say you had theta equals to negative 11 pi over 4. So this angle here is clearly out of the range of 0 to 2 pi because it's negative. So to bring it into the range, all we have to do here is add 2 pi to it. And so since 2 pi is the same as 8 pi over 4, we're going to have this angle equivalent to minus 11 pi over 4 plus 8 pi over 4. And that should give us negative 3 pi over 4. And as we get to this particular point, you should be quick to notice that the angle is still out of the range of 0 to 2 pi. And so we're going to go ahead and add 2 pi again. And so this particular angle is going to be equivalent to negative 3 pi over 4 plus 8 pi over 4, which should give you 5 pi over 4. And so with that, you can see that this particular angle is stuck between 4 pi over 4, which happens to be pi, and 6 pi over 4, which happens to be 3 pi over 2 right here on the bottom. And so the positive acute angle theta prime that is formed at the terminal side and the x-axis is going to be equal to 5 pi over 4 minus 4 pi over 4, which is equal to pi over 4 in radian. And so with that, we are done. As always, if you like a free PDF copy of this particular note, check out the description below. And don't forget to subscribe to get my future videos. Finally, if you like the way I break down the material, give me a thumbs up and I'll see you next time. Bye-bye.